Welcome everyone to the 2020 APEC Groundbreakers virtual tour by APEC OUC. This year our event would be the biggest one ever, with 174 sessions, including normal sessions, workshops and hands-on labs from 123 different speakers over 11 days. Also, it would cover sessions in 4 different languages. Please remember to register for as many sessions as you can. All sessions will be available for replay as many times as you want for 2 weeks after the initial session date and time. You can also interact with the speaker at any time during those 2 weeks by posting questions or comments directly in the playback session page. Can you see my screen?
Yes.
Okay. I would like to say thanks to all user groups and Java user groups that made this event possible, and also to our sponsors, Oracle Groundbreakers and CloudDB.
Oh, I don't see that screen or that slide. I see a Zoom browser.
Right. What happened here?
I'm surprised it's not working.
Yeah.
Here we go. We're getting closer. No. Oh, well. There we go.
Yeah.
Success.
Now for today's session, Parsing with Plan Change Detection and Analysis using ASH Data by Craig Shallahamer. Please feel free to write questions at any time during the session using the Q&A tab of the Zoom webinar, and the speaker would be answering them at the end of the session. If you experience any issues during the presentation, please feel free to contact me at any time using the chat tab of the Zoom webinar. Now, without any more delays, I would like to leave you with this amazing session by Craig Shallahamer.
All right. Hey, thank you very much. I'm going to, first of all, it looks like you can hear me. You can probably see me, but I need to share my screen. So let me do that. And we've got the recording. Good. Can you see my screen? Okay.
Yes, that's good.
Okay, fantastic. So I'm going to make myself very small on my screen. Yeah, and if anybody has questions, go ahead and type those in. And as soon as I see them, I will try and answer them right away. Okay. And of course, at the very end, we'll check and make sure all the questions are answered. And if not, you can always email me. So welcome to the presentation. We're going to be talking about how to use ASH data, but in some unusual ways today. And I'm going to mention 3 ways, but really our focus is just 2, I think, really powerful ways to use ASH data that are very unusual. So just a little bit of a background before we get into it. So for me, I mean, ASH provides just an amazing storehouse of very detailed session level activity. And that makes it really unique and very powerful for us. And kind of, what I initially focused on with ASH was to really dig into what I call performance incident. So that's like when, performance is really good and all of a sudden, bam, performance is really bad. And then everything's good. And people look at each other like, what just happened? And if you ask them to say, or if you ask them, hey, can you show me what just happened? They're like, no. And I say, well, why not? And the answer is usually, well, it just kind of happened like randomly. And if you try and solve that with an AWR report, it's not going to happen if it's a small group of users. And sometimes it's even difficult if it's a large group of users. But with ASH, because of the sample nature of the data and because we're dealing with sessions at the session level, we can actually solve most of these problems. So what I'm going to do today, I'm going to use mainly some scripts from, I call my ASH scratch pad, and anybody who does a lot of ASH work, they usually have a text file. I mean, if they're honest with you, they'll say, oh yeah, okay, I have a text file and I have my ASH scripts in this text file. I just copy and paste and modify them and all that. So that's essentially what I've done. But I only have 5 or 6 scripts. They're all really controlled through SQL plus defines, and you'll see me set the defines, and then I'm going to run. I think I just run 2, maybe 3 of those scripts in that Scratchpad. But you can download those off my website anytime. The Scratchpad's been around there forever. And then I have my Bloodhound toolkit. I use that. The output is formatted a little bit nicer, and you can do some more advanced things, but it's not just a flat, ASCII file. I mean, it's SQL text. It's a text file, but it's not I don't know. You don't copy and paste it. How about that? All right. Okay. So the question I've asked myself is that, okay, so I can do the incident analysis, and it's a lot of fun, and that's been successful, but I know there is a lot of columns in ASH, a lot of columns, and I typically only use just a few of those. So I was asking myself, okay, so Craig, I wonder if there's some really unusual, unexpected, really powerful ways that we could use some of the ASH data that are just mind-blowingly really good and leverage the ASH data. And the answer is, well, of course, yes, because that's what I'm going to be talking about today. We can do some really amazing things with ASH. And so the ones I'm going to focus on is to detecting plan change. And then when we do that, we're going to drill down to the session level and confirm what we see and some other things. And then what I think is one of the most powerful things we can do with ASH data has to do with parsing. Detecting parsing even before it becomes a big issue. And then when it is an issue, we can drill down and we can figure out exactly the SQL, where it's coming from, all sorts of stuff like that. And so I probably like half of this or more of this presentation is actually demos. And I've actually recorded the demos just in case I had like a major failure and that would just screw up the whole presentation. So we'll be getting to those here actually really quickly. So I want to quickly introduce myself. So my name is Craig Shallahamer. I'm based in the US, and I started working with Oracle in 1989. So I've been doing this like forever now. And I do a lot of predictive analytics, machine learning work, but most DBAs know me through my performance tuning work, and ASH is a reflection of that. I do a lot of performance research, like projects, little experiments, and those have been posted on my blog. So if you looked at my blog, you'll notice it's pretty much a series of experiments that I actually run it in a controlled environment, and I just talk about what we can learn from the experiment, what we can learn from those experiments. So I've written a couple books. Really proud of those books. They take a lot of time, but yeah, they're great. I do a lot of conference speaking, teacher, mentoring of Oracle DBAs primarily. I'm an Oracle ACE director. And I really enjoy user groups. User groups have been a big part of my Oracle experience. And so I've been the track manager, the DBA track manager for the IOUG conference for a bunch of years now. And that conference has merged with another conference called Quest, which is like PeopleSoft and JD Edwards and stuff like that, and eBusiness Suite. Anyway, so that's a little bit about me. The company Orapub, it's got a really interesting history, but I'm not going to tell you about that. So Orapub serves Oracle DBAs who want to take their Oracle skills to the next level. And the two main areas are performance tuning, like performance diagnosis, things like ASH, AWR analysis, and machine learning as well. So there's tons of stuff on our website, things like this presentation, got a bunch of free webinars. But my really primo material, I save for Orapub, for paid Orapub members. And so I do a couple webinars like every month, and just for the members, and we have and a bunch of other things, discounts on my live training and things like that. So if you're interested in that, check out the website. Well, this is not a machine learning presentation. I do want to mention this though, because a lot of DBAs have no like real exposure to machine learning other than presentations where somebody just kind of just talks about different algorithms and things like that, or like, hey, it's the future, you better get into, this kind of scare tactics almost. So if you actually are just curious and you want to know if this is something that you might be interested in, I have like a free, it's an 18 section e-course, it's like an email course, and it's all in Python. And you just copy the code, you paste it in Python, and I just kind of walk you through it. It's really good. People love it. Hundreds of people have gone through this thing, and you will learn very quickly if machine learning is something that you're interested in or not. So it's just, www.orapub.com/ml for machine learning -e-course. Fill out the form, boom, you'll get the first email in a couple of minutes, and it's up to you what you want to do from there. All right, so I want to make sure I mention that because I'm pretty proud of that. That seems to really help DBAs know if this is something that they're actually interested in. So let's get a little bit of background here. Okay, so our performance analysis options. Okay, most of my experience and most of my time is spent really working with AWR reports, and that's based on Oracle's time model. We're looking at how long something takes, intervals, CPU, non-idle wait time. But I much prefer to work with ASH. But I think it's why I deal mostly with AWR reports is it's so easy for people to generate an AWR report and just send it to me. You can't just send me your ASH data. That's a little more involved, and people get a little uptight about that. It's too bad because with ASH, we can solve things quicker with more detail, and our solutions are much more convincing because we can clearly demonstrate like where the problem is, that kind of thing. I do some Oracle tracing, but it's very rare that I need to actually do that. But I just want to shout out, that's probably a better term, that if you're not familiar with DBMS Monitor, that is a really awesome package. It's been in Oracle since I think Oracle 10, something like that. And you don't pay extra for it, but it allows you to trace just sessions that meet certain criteria. It's really powerful, and a lot of DBAs don't know about that. So I wanted to mention that. But if I do Oracle tracing, that's how I actually try and do it. But we're going to focus on ASH. But to understand ASH, since it's like, active Oracle sessions, we need to know, well, what is an active session? So real quickly, let me just kind of explain that. So let's say we have a SQL statement that's actually running. So it's either going to be, if it's active, right, it's either going to be burning CPU or it's waiting on a non-Oracle wait event. There's no third option so far, okay? Burning CPU or waiting on a non-idle wait event. So let's go left to right. So it burns like CPU for 5 units of time, and then it's unable to burn CPU for some reason. And there's going to be a reason why it's unable to burn CPU. And the wait events give us clues about why the session is unable to burn CPU. So it starts burning CPU, then it waits 4 units of time. Now it can burn CPU for 3 units, waits for 2, we burn CPU for 6 units of time, and then boom, it's done. Let's say the SQL statement's done. One statement, it's actually touched like 300,000 buffers, it's done 300,000 logical IOs. And if we look at if we add up all the CPU time and the non-idle wait time, that's going to give us 20 units of time, and that's going to be the elapsed time, which should be really, really close to the database time. Sometimes it's not. And actually, that's in this presentation, we're going to talk about that a little bit. So this is important. It's really important to understand that a session either burns CPU or it doesn't, or it's waiting on a non-idle wait event, because that's going to set us up for talking about ASH. Okay. Now, let's say we run an AWR report, and we do our time-based analysis, and we set up our framework. We simplify this crazy complex AWR report into something that we can understand, and it clearly shows that the problem is really, it's about CPU consumption and tons of physical read IO. Okay, that's what the AWR report shows us. But then we get a phone call from a few users that say their screen just randomly just locked up for a minute. And we're thinking, okay, so I'm listening to the users on the phone, like I'm looking at the AWR report, and it's like there's a disconnect. it just doesn't make sense. The CPU consumption and the physical IO just does not match with users saying their screen actually locked up. I've seen some really slow IO before, but not that locks the screen up like that. So something's not right. And the reason is it's because by design, an AWR report focuses on the entire instance or the rack cluster. But these users are not impacting significantly the activity on the instance. And I like to say, like, an AWR report shows us, it's like the ocean of activity. It's like this big river with this current, and the AWR report shows us and gives us information about that current. But if a few users are having a very different type of experience, that gets kind of buried. It's like they're small fish in a big river and they're swimming upstream, and we don't even see that in an AWR report. But they are sessions that were active, and therefore they're going to be sampled by ASH. So if we want to figure out and understand those few users that are kind of swimming upstream and are not with the rest of the flow, then ASH like comes to our rescue so we can actually solve these incidents that are random and can happen very quickly with just a few seconds perhaps. So that's what we're actually going to get into. So we need to know how ASH actually works, because to really use ASH, we have to take advantage of the sample nature of ASH. And as DBAs, you know, when we learn about Oracle performance, it's almost always based on Oracle time, CPU time, non-idle wait time, categorizing and classifying the time, all that kind of thing. But ASH is, while we can do some of that, it's a completely different mindset. And it's difficult for DBAs to get this because it almost goes against what we've been trained. So just, you know, if you're familiar with this, just relax for a second. You know, we're just about ready to get into the plan change and the parsing stuff. But especially if you're new to ASH, this is really, really important to understand. So what ASH does is, like, every second by default, it actually takes like a picture of all the active sessions. So it's kind of like if all of us are in the same room right now, okay? And I have like this special camera. Let's see, I got here, we'll use this. This is like my special camera right here. Actually, here, this is better. It's got the little thing right here. This is my special camera. And what I'm going to do is, when I snap my fingers, I'm going to get a picture of everybody. Like, we got a picture. And then we're going to get a stack of pictures like this. Okay. And every one of these little pictures in the stack is a picture of you at your desk. And there's certain characteristics that this picture actually shows. Okay, so what I'm going to do then, just like a few seconds later, I'm going to go like snap, and like we got another stack of pictures. Now, this camera is so good, it's only going to take your picture if you're at your desk. So when I took the picture the first time, let's say a lot of you were at your desk, so we have a big stack of pictures. But then the second time I take pictures, only a few of you are at your desk. And so then I do it again. I'll take another picture, another set of pictures, you know, got all of you guys. And like, whoa, everybody's at their desk in a big stack of pictures right here. And every single one of those pictures has a bunch of information about what you're doing at your desk. Things like what's on your screen. Are your hands on the keyboard? Really creepy stuff like, what color is the shirt that you have on? Do you have a cup of coffee on your desk? What is actually on your screen? Are you watching Fox Sports right now, or are you looking at OEM, or are you doing something else? Really good camera, a lot of good information right here. So what I have here is each little picture is an individual sample. And so what I with all these samples, I can look at them and I can ask a question like, what are most people watching on their screen? And hopefully it's not Fox Sports, right? But it could actually be like that, right? Or another thing, somebody might say, let's say your manager comes to me and says, hey, Craig, what was Fred doing today at 10:37? And I'm like, well, let me look. And I find a picture of you at 10:37. I'll say, well, Fred was at his desk and he did have Fox Sports on there, and that kind of stuff. So we can get really, really, really specific. And the kind of questions we can ask are amazing. Now, Ash is kind of like that, but it takes pictures of all the active Oracle sessions by default once every second. So every second, we're going to get another stack of pictures. And only the sessions that when the picture is taken, if they're burning CPU or they're waiting on a non-idle wait event, only then will they get their picture taken. And with all those pictures, we can ask all sorts of questions. And here's some of them. Now, some of these questions you can answer by looking at an AWR report, but the really cool questions, the really tricky ones, not a chance. There's just no way you're going to be able to do that, but we can with Ash data. And the way I've kind of summarized the different reporting requirements that I've had with Ash, the first one is kind of like, it's a summarization of what's going on. Kind of like I profile what's going on the entire instance, kind of like an AWR report analysis when I set up my time-based analysis. But we can also profile like the SQL ID, the module, or a section, or a particular program, something like that. And the classic is the top anything. Like, what's the top CPU module? What's the top CPU session? What's the top session that's waiting, running a specific SQL ID when the wait event is DB file sequential read? I mean, you can it's mind-boggling, the stuff that you can actually ask. We can actually summarize all the session activity, and like, let's say over a 30-second period, and every 30 seconds gets summarized in one line. So we can kind of just look down and see what's happening, just scan down to what's happening, little summary by summary by summary, and we can just understand what's going on, let's say at the instance level. One of the really cool things, which I'm going to show you, is we can do what I call like timeline a session. Once we've identified a session that's interesting to us, we can look at it Ash sample by sample. So it's kind of like if we got a stack of all these different pictures, I actually like pull out, oh, there's one picture that I need. There's another picture of the session. There's the other picture and another picture. And I put them all together, and I can kind of like flip through them like a cartoon, and I can just watch the session in kind of like in real time. It's amazing what you can do. Sometimes things are pretty complex, so we create some really cool visualizations, and yeah, that's pretty neat. We can do that. I've given some demos on that using Python and R. I've got some really cool visualizations on things, and then you can actually use Ash to infer the runtime of statements. You can actually do that, and I'll refer to that, but I'm not going to focus on that today. But that you could, my last script in that scratch pad I mentioned, I actually, that's all about inferring runtimes. So let's actually, let's see if we can do just a little bit more. And so what I want to focus on first is plan changes. So to do that, I got a little recorded demo. I'm going to walk you through this on this one. And now it's going to be bigger than this, so don't panic yet. Okay. So here we go. All right, I'm gonna get this so you guys can, actually I'm gonna get this as big as I can. I'm gonna slide myself out of the way here. I gotta make sure I can see it. My camera's right in front of me. Actually, I'm gonna leave it like that. Here we go. So we're gonna start this. All right, so we're gonna talk about plan change, detection using Ash. All right, so we're going to log onto my super, secure system here, and we're going to use DBA hist. I'm really tired right now. We're going to use DBA hist active sesh history. Okay, we could use $, if you wanted to look at what's happening right now, but a lot of times when we deal with incidents, especially if it happens, later on, I might not know about it when it's actually happening, and the information might not be in the Ash ring, in $, active session history. Anyways, okay, what are the key columns here? Well, we're looking at plan changes. So the SQL ID is going to be really important because we want to know what the plan changes for a particular SQL ID. Okay, a lot of times I want to know the child cursor number as well. So we're going to have a cursor we have a child cursor. The SQL ID or and the SQL text is associated with the parent cursor, and the child cursor, when we have multiples of those, that like the plan hash value is actually associated with a particular child cursor. Although multiple child cursors can have the same plan hash ID, but they can be different. The other important column is going to be the SQL plan hash value. So really the two main ones are, of course, the SQL ID and then the plan hash value. So just with that, if you can think of it like this, we have when the picture is taken and we look at one of the samples, it's going to have the SQL ID and it's going to have the plan hash value right here. So if I have a stack of your pictures right here, or let's just do it like a timeline, kind of like this. This is the first one. This is the second one. If you're running the same SQL ID, so it'll be the same SQL ID on both pictures right here. But one of them's going to have a plan hash value of maybe ABC, and this plan hash value is ABCDE. You're like, hey, it changed. And guess what? This is like right when the user called and said there's a problem with, performance, something like that. And so then we know there was a plan change. So what our strategy here is we're looking at primarily, but it doesn't have to be, I'll just say, sorry about this. We're looking at when the SQL ID is executed. It could be from a same session, could be a different session, but it's the same SQL ID. But all of a sudden we notice in kind of the life of the SQL statement, there's a plan change. And that's when the users call. And so we're thinking, and then we can analyze the run times and we can see, well, gosh, for this SQL ID, is this an unusually long runtime? Okay. Now, in addition to the SQL ID and the plan hash value, it's really helpful to know if we're looking at the same execution of the SQL statement or multiple executions. Okay. The way to figure that out is you look at the SQL execution ID and the SQL execution start time. You need both of those. I've never been misled, to my knowledge, that this is a unique execution of the SQL ID for a particular session. So I'm gonna bring that into this whole situation as well. All right, so let's continue on with this. All right, so here's a situation. Okay, operations context used because the user, a particular user called always surprisingly slow performance, but we have a date and we have a time. And OEM actually shows the SQL ID, so that's pretty cool. So we want to find out, hey, has the plan changed? No, that's just what I want to do in this example right here. So we're going to drill down to the session level. We're going to timeline, and we're going to make some recommendations. Okay. So, this is kind of this isn't really rocket science, but if there was, this is kind of the rocket science here. So what we're going to do here, I have an inner select, which is basically just going to give me like my raw information. And then my outer select is where I kind of format it in a particular way. This is how I really developed a lot of my tools. I get all the raw stuff in the middle, and then I make it look pretty with an outer select. It really helps me with debugging because I can actually run the inner select and I can kind of tweak it just till I get it right, and then I can make it look good in the outer select. All right. All right, so here's the key right here. All right, you see we have the SQL plan hash value. That is the current SQL plan hash value. Okay, so like if I have these two samples again, if this is the most recent snap, then this is with the SQL plan hash value, that will be the current SQL plan hash value. But what we need to know, we also need to know, well, what was it before that? The previous SQL plan hash value. And so to do that, we're just going to use the lag function right here. And we're going to lag one and for the SQL plan hash value. So that lag is going to be the previous SQL plan hash value. That's really the whole thing in the script right here. And so on the outer select here, I got a little case statement. So when the current SQL plan hash value does not equal the previous SQL plan hash value, hey, then I know, yes, there's been a plan change. And so that's really the core of this script. And that's going to help us to identify when a plan or a different plan is being used kind of in the life of a SQL statement. There's different ways you can approach this, but this is just one way, and it's a good demonstration of this. The other thing I want to introduce you to here is you see I'm running this in SQL Plus. So I'm already using some SQL Plus defines that I use in my Scratchpad. And so I'll just kind of introduce those to you right now. The first is going to be, you see, I have select and then some columns. This allows me just to specify the columns that I want to see. No surprise there, but I can just change that to fine without actually rechanging the SQL. So it's really easy for me to change the columns when I can just rerun the same SQL statement and boom, you know, I get different output. One of the things I always do at the beginning, of course, is I need to set my data source. And my data source for this one is going to be DBA hist active sess history. And if I'm using DBA hist active sess history, I'm probably going to want to set the database ID and the instance ID, and I do that in that define right here. I also almost always I'm setting some kind of timing details. Like I call this part of the scope of the analysis. So remember, the user had an issue at a particular time. What time was it? Like, was it 17? Whatever, I don't know, whatever it was, I forget. So the timing details, we're going to start at least an hour before they said they had the bad experience. And then we're going to end about an hour after, because users rarely tell me when the problem actually happened. I mean, they do their best. So I need to be, I don't want to miss it. So I always look before and after, and especially for what we're doing here, because we kind of want to see the life of the SQL statement. It's good to see, you know, well before the problem. Okay, so we're going to set a couple of those defines. You'll see me do that right here. Okay, so I'm setting the actual the sample time that needs to be greater than 1830 right here, and it's going to be between like the 1830 and the 2130. So you can see I'm giving myself plenty of time on either end of the issue. What was the issue? Was it like 1930? I think that's when they said the issue. Anyway, so that's that define. Okay, and see what else am I going to set here? Okay, I have a filter. Okay, that just basically does nothing right now. 1 = 1. And the columns that I want to see right now, I just want to see the SQL ID and then the child cursor number. Okay, I do set the data source, but for some reason that's not recorded. You don't actually see that. So okay, so there's the SQL. Let's go ahead and run this, and boom, here we go. All right, so the user called was around 1930, right? So, and we know this is the SQL ID because operations told me on OEM, this is the SQL ID. So, oh yeah, that's part of my filter right here. Darn it, where SQL ID is, that SQL ID. So I'm only looking at this SQL ID. There's only one child cursor right here. It's only child cursor 1 is involved. And you can see as we kind of go down the sample time, right around when the user called, around 1930, we have a plan change right here. See, there's the current plan. That's what it was before. We got a plan change. So it's like, boom, it makes sense. What I'm trying to do right now in this whole incident analysis is I'm trying to make sense with what the user is saying, with what the data is telling me. And I'm pretty happy when I see something like this, because it's like, hey, I got a time match. They had a bad experience. Hey, guess what? It looks like the plan changed. But now I need to actually drill down to the session level. And then once I need to do that, I need to figure out, well, where is this SQL, in the application? I almost always need to figure that one out too. All right. So now that we've actually, figured that part out, now let's drill down to another level. So we're going to add the SQL execution start time and the execution ID. Now I don't show the full date. All I'm looking for is that if I want to be able to tell if the SQL statement, if it's one long running statement or if it's being repeatedly executed. And you'll be able to see this in just a second what I'm talking about. So let me go ahead and just run this. By the way, it's the same SQL. I just changed the defines. Okay, so here's the situation. Here's the sample time. And you'll see right around 1933, okay, this is when we see the plan change right here. Okay, so this is the line that we were looking at before, okay? Now now if I just look at the sample time, and we know this is the same SQL ID, if I look at the sample time, I see 1933.50, 34.0, 34.10. I'm thinking, okay, one sample every 10 seconds. That's AWR ASH data. This is just a longer running SQL statement. Wrong. If you look at the start time, 33.49, 33.59, 34.09, these are 3 different executions from the same session, same SQL, same session, same SQL ID. By the way, it's always a combination of the start time and the execution ID. And both of these are actually different here all the time, which is kind of convenient. So we know that these are 3 different executions. This is the same session, have the same SID, session ID, and serial number, but it's the same SQL ID. So one of the questions is, why is this guy running the same SQL statement 3 times in a row and having a bad experience? I mean, I don't know, maybe it's just keep pressing the keyboard. I don't know that, but that's something that we can actually see by looking at this data. So what we're going to do now, though, now that I know the session, we're going to like timeline or stock the session, and we're going to use ASH data to actually do this. So we should see this same kind of information when we actually look at that session in detail. So that's what we're going to run next. So the script I use for this is in my ASH Scratchpad. It's an insanely simple script. It's like embarrassing to show you guys this, but it works so good. I'm going to risk it anyways. But in the ASH Scratchpad, right? So it's a text file. I just have one of the little sections is I call the common column formats, and I just copy and paste these, and it just kind of sets the stage so the reports don't look like total crap right from the get-go. So this is the SQL, all right, for my timeline. It's really simple. What's the sample ID? Okay, what's the ASH sample time? I want to know the session ID, the session state. The session state is either going to be on CPU or waiting, and then any columns that I might actually want to see. Okay, so this report typically can get very wide with a lot of columns. So I don't want to suppose or just kind of guess what columns that you're going to want to see, but you're going to want to see these main ones right here. And then you just add the ones that you actually want. Okay, now we're still going to be looking at the same data source, DBA hist active sess history. We're still going to look at the same timing details, right? You know, that hour before and hour after the incident, that kind of thing. And I did set somewhere, I set the database ID and all that. And the where clause, well, let's see, what would I do for the where clause here? Well, I'm looking for a particular session. So in my where clause, I'm going to want to set where the session ID is that 1589, and I'm going to set the serial number. Now, one thing I've learned with Oracle, especially when I'm looking at ASH data, I need to set both the session ID and the serial number. And if I'm not sure that I'm looking at the same session serial number, then I will actually need to show that as part of the ASH columns. I'm telling you, it's weird, but the session IDs are reused. It just seems strangely frequently. And what makes it unique is that session serial number. So just kind of a hint, because it's really easy to mess that up. And you think you're looking at the same session, like the same user. No, it's not. It could be totally different. So watch out for that. Okay, so let's stock session 1589. All right, so we're gonna scroll up here. Boom, here we go. Here's the sample time on the left, the 1933. We've seen this before. These are the 3 samples right here, okay? So I like this because we can see like this is a bigger scope of what the user is experiencing. But what we're focused on is they're waiting, okay? DB file sequential reads, single block reads. There's that SQL statement. And there's the plan right there, okay? Now, from this, I can't tell if these are 3 executions yet, or just a longer running SQL statement, because I don't show the SQL, I don't show the execution ID yet. Okay, so I'm going to show you that in a second. But one thing I look for here is does this kind of look like just a normal user experience? Like, you know, they're waiting, they're burning CPU, there's some sequential reads, we got another wait event, they're running different SQL statements. It's not like they're just locked waiting. You know, they're actually flipping between different statements. So it's like this user is just kind of doing stuff. All right. So that's just some observations, and they're very active. Okay. So what I'm going to do here is I'm going to add the execution start time and the execution ID. And this is we'll lock it in. Now we know this from what I showed you earlier, but if you actually show other people kind of the life of the SQL statement, one of the things that you're going to want to know, is this just like a longer running SQL statement where we have 3 samples, or is this 3 executions? And it is right here. So it's like, okay, I don't know why, but this guy ran this 3 times in a row. Okay. The other thing we're going to want to find now is, well, where is the SQL statement? Right? I mean, you know, people, it's easy to tell people, hey, this is the SQL ID. Okay. But it's really helpful when I can say, well, when this guy was running the SQL statement, this is the module that the SQL ID came from. And so then it helps them go to the developers or the vendor or whoever it is to actually work on the SQL statement. Now, sometimes people actually know the SQL statement. They're like, oh, yeah, we know about that statement, Craig. All right, that kind of thing. But sometimes we don't. So this is production data. That's why I kind of blued that all out. I didn't want to give it away. So this is those 3 samples right here. And sure enough, there's the module right there. So clearly this is an AP user right here we're looking at. And we don't know why, but he ran that SQL statement 3 times. So where's the statement? It's in the module right there. At least this time that the statement is actually running when the plan changed. All right, so I think that's about it for this one. Yeah, so that's detecting plan changes. And all right, so let's get back to the slide. So that was the demo. That one's okay. That's pretty cool. That's not super cool. Okay, we're going to show you. The next one's going to be better, but let's just kind of summarize what we actually found here. Okay. Oh yeah. Oh, by the way, one of the next steps would be to know, well, how long does that statement typically run for? Okay, I find that is really, really helpful. So I would actually then go, I don't show you this, but I would actually take that SQL statement and I would do some analysis and figure out, well, what's the typical runtime of that statement? Or we can say, what's the typical runtime for that plan that they just actually started running? Is that a bad plan? I'll quote longer running plan or not? You know, that's really, really useful information, but I didn't show you that. So let's get a little summary of this right here. All right, so we used the key ASH plan related columns to detect the plan change for a given SQL ID. Okay, that was the first thing we did. Okay, then we drilled down to the session level. Okay, and we could actually see that the SQL statement was actually run multiple times in succession by the same session. Okay, then we figured out, well, what's the module, so we can actually figure out, hey, who's responsible for the SQL, and then we could actually infer the SQL statement runtimes, and we can do that, and that's in my Scratchpad script. All right, so that's how you can detect if there's plan changes. Now, I mentioned before, you know, there's different. I mean, you don't have to follow the same process I did. It was, you know, but if you know those columns are there and you know that, hey, the plan, you have 2 different samples and the plan is different, we know that it's a different plan. Okay. And so that's one of your clues that, hey, they might be using a brand new plan here that may be a bad plan. Okay. So on with parsing issues. All right. So that was the plan change part. That's useful because a lot of times when a user has a bad experience, one of the first things we should do, and that a lot of times we'll forget, is, well, maybe it's just as simple as the plan just changed. And so we could use that to figure that out. Okay, one of the really, really difficult problems for Oracle DBAs, I think, has to do with parsing issues. And one of the challenges we have, so I like to show this picture here, is that it's because a lot of times parsing is already starting to bubble up, but we don't know it. And then it just goes nuts. and it just explodes. So the question is, well, why couldn't we see that before? I mean, why couldn't we see that before? Well, there's some really good reasons why we couldn't see it before. If we look at an AWR report, one of the things that makes AWR report analysis, and why, like, I think kind of the future of Oracle performance analysis is an sample-based ASH, not time-based AWR reports, is because of stuff like this. So the database time should equal the database time should equal the DB CPU plus the non-idle wait time. So if I add up the non-idle wait time right here, don't double count the DB CPU, just add up the non-idle wait time. And if you add this all up, the DB CPU and the non-idle wait time, it comes out to right around 63,000 seconds. Okay, this is over the snapshot interval of the AWR report. But if you look at the reported database time, it's like 86,000. We're like, well, that's kind of weird. Okay. Huh. All right. And this kind of thing, here's another example of this. Now, does this happen often? On AIX, it happens like practically all the time. On Solaris, on Linux, not that often, but it does happen. And typically, and I would say typically, when the system is really stressed, like a really nasty CPU bottleneck, this kind of thing can happen. Now, my objective is not to talk about what do we do about this. My point here is that this can happen. And so then it leads us, it makes things difficult and brings confusion when we look at like DB CPU and it says, okay, over the snapshot interval, all the sessions have consumed like around 2,200 seconds. And you're thinking, well, is that number right? Is DB CPU correct? Because the numbers didn't add up right. So can I really trust that number? And that's a really good question. And the answer to that is something I'm not going to get into right now. But my point is that if we're trying to find out if there's parsing issues and CPU is involved in that, then it's really nice if we can fully trust these numbers. And sometimes we can't. There's some other stuff potentially going on. So how do I tell if there's parsing issues? Okay, well, in an AWR report, one of the best ways to tell is if there's some parsing issues going on. Not that we're going to be able to figure out not that we're going to know how to figure it out or what SQL is involved, but if there is an issue potentially brewing, is this percent of non-parsed CPU. So this is kind of a double negative. So if you look at the number here, what this means is just over 3% of the DB CPU, the CPU, is related to parsing. Okay, so that gives us a really good clue. And we can also tell that this cursor pin S weight on X, that can be related to parsing as well. And that's not, from a time perspective, that's really not significant, but it's kind of brewing there. So it's not like we have a full-blown parsing problem right now, but this, oh, by the way, this ratio right here I'll say on a healthy, typical OLTP system, this is like in the 99s. So that's like, that's kind of unusually low for most systems, okay? And I got DB-CPU, but do I trust that? But I got some cursor pin S, but it's really not significant yet. Man, do I have a parsing issue or not? And how bad is it? And if I do, what's the sequel so I can actually potentially fix this thing? It's really difficult to do that with an AWR report, and it's problematic. So what we need is a totally different solution or way to solve this. And ASH gives us a way out of this scenario, and it works really good. It works really good. So what I'm going to do here, I got another demo. I think you should actually really like this one. This is super cool. So what I'm going to do is to save a little, I'm going to save a little bit of time here. I was just going to show you, well, let me show you the first, let me just show you yeah, I got to show you the key columns first. All right, because I actually want to skip some of it here. Okay, so what this is going to be like it's live recorded, but we're looking at $V active session history. Now, the rocket science, how this works, and there's a bunch of untapped goodness waiting for us to exploit here, is in the ASH, view table, whatever, are these in columns. It's IN underscore, and you can see a bunch of them right here. They're all one character. Every one of these has either a capital Y or a capital N in them. And so if we're looking at an actual sample and one of these is a Y, this tells me that the session, when the picture was taken, they were like in whatever that thing means. Okay, and there's a lot of them right here. So what we're looking at is the parsing related ones. If we look at a particular sample and the in parse is a capital Y, we know that at the moment that the picture was taken, we actually caught the session in the middle of a parse, which is really rare because that should happen very fast. And within the whole parse, that's all the parsing, I'll say all the what goes into a parse, part of that could be a hard parse, right? The first time it's got a hard parse. And so in addition to just parsing, we can also tell if the picture was taken right in the middle of a hard parse. I mean, come on, that is so awesome. And it's so rare to catch a session like the picture taken, not only in a parse, but in the middle of a hard parse. Okay, these are the two columns that can tell us the SQL that is actually doing a lot of parsing and doing a lot of hard parsing. Okay, so I'm going to show you how we can actually use those columns and to actually solve a real problem. So I'm going to skip some of this right here. Blah, 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 blah. Okay, so here we go. Okay, so what we're going to do here is that, our data source is going to be the $V active session history. And we're not using DBA hist, so I just need where 1 equals 1 and the timing details. Okay, we're just going to look at the last 1 minute of data, of activity. Okay, so we're going right at what's just recently happened, and that's going to be in the $V ASH, what I call the ASH ring. That's where it's going to be. And what we're going to look at right now, since we're just trying to understand how do we detect parsing using ASH data, I really don't care if the session state is CPU or waiting. Just if it's active, I want to take a look at it. Okay, so let's actually look at some of the, let me show you how we can actually do this. And then we'll actually I'll show you this for real. All right, so did I stop it? Yeah. Okay, so here we go. So how do I tell if a session is not parsing? Well, it's really simple. I just do a sum decode. So if the in parse is no, and I sum all those up, that's the number of sessions over the last minute, all the active sessions that were not parsing. Okay, and I can figure out, hey, add up all the sessions that are in a parse, and that'll give me a total right there. Now, it does match. You notice I don't just add these two together and say that's the total number of active sessions. No, I'm not going to do that. This gives me the count of the active sessions. This will give me the total of the sessions that are not parsing, and this will give me the total of the sessions that are parsing. So the count of active sessions should equal the sessions that are not parsing and the sessions that are parsing. And as we'll see, good news, right? If that didn't work, then I'm not sure what I'd do then. The other thing here, we have this in hard parse. So I can basically sum up all the sessions that are in the middle of a hard parse. Okay, so in order for the hard, and this has always been true every time I've looked at it. Okay, if a session is in a hard parse, then they're also in a parse. So that's why I said before we have parsing. Well, hard parse is the inside that will only happen the first time when we create the cursor. And then we have the larger parse right here. Okay, okay, I think I'll stop there. You got that. All right, so let's go ahead and actually run this. All right, and then we're gonna use this to actually solve a problem. Okay, so this is a pretty, this is a loaded system. I'm causing a problem here. So over the last 1 minute, there are 375 pictures right here, active sessions. Of those 375, only 51 are not parsing. 324 are actually in the middle of a parse. So if you add the 324 and the 51, we get the 375. Okay, you should never ever see a system like this. I am putting a load on the system specifically to demonstrate this. So you would never ever see something like this. I mean, I hope you don't. I never have. All right, so we got 324 sessions that we caught in the middle of a parse over the last minute. I should say session samples, okay? And get this, 249 of those we actually have samples that say, not only did they say parsing, but they say hard parsing. That's insane. Okay, that's crazy parsing activity right there. And you can figure out all sorts of ratios and stuff like this. Okay, what I'm going to do here, I'm going to set cursor sharing to force, and because right now I'm using the default that's exact. Now, if I'm using cursor sharing force, SQL statements that are similar yet distinct textually are likely to have the same force matching signature. And when cursor sharing is set to force, Oracle can actually use that. So in other words, it can share the cursor, all right, which is really great for memory management and some concurrency and some things like that. So what you're going to notice when I press enter right here, you're going to see the sessions that are not parsing, that's going to start to go up. Remember, these are all the active sessions over a 1 minute interval. Okay. All right. So you're going to see this number start to go up. And then you're going to see the number of sessions that we catch parsing and hard parsing. Those should start to go down. Notice we'll get a little bit of CPU time back, but not a whole lot. And I don't want to get into all the CPU stats, but you'll notice here, you can see sessions that are not parsing, 51, 61, 65. This is an example of cursor sharing equals force. Sessions that are parsing, 327 drops to 301, drops to 295. Look at the hard parse, drops from 248 to 222 to 215 right here. Okay. All right. So we can actually detect this. So let's actually look at an actual situation here. So I'm going to set this back to exact. So here's the situation. Okay. The application is not fully instrumented. Surprise. The application does not use volume variables, and cursor sharing is not supported. Now you might say, well, that's ridiculous. No, well, it may be ridiculous, but the vendor just doesn't support that. So they're saying, no, we don't use force. We've had some bad experiences with that. Whatever it is, it's not supported by the vendor. So first of all, we need to do, we need to investigate and confirm that there really is a parsing issue. And then we need to find the SQL. Now, this is more complicated than just finding the SQL statement with a lot of in parse or in hard parse. It's way more complicated than that. And this is, and Ash will actually allow us to actually solve this. So it's pretty cool. All right, so here we go. So this is, we're gonna use a scratch pad for this. I'm gonna use my profile script for this, which is just, kind of summarizes. So I got to set, my basic, right? My basic stuff right here. This $V session activity is my source. We're gonna look at just the last minute of activity. Because you can profile the entire instance, a particular SQL ID or a module, like whatever you actually want to, however you actually want to summarize the situation, but it is a key value kind of thing. So what I'm going to do, I'm going to say, I want to sample all the sessions over the last 1 minute where the sample ID is anything, which means all of the sessions. So it's the entire instance. I know that sounds kind of strange, but I could have said I want to sample all the sessions over the last 1 minute where the SQL ID is ABC123. But this, I want to look at the entire instance right here. Okay, so let's go ahead and just run the SQL. This is straight from the scratch pad, just copy and paste it. This is the top part right here. So by the way, you'll see I have an inner select to give me kind of the raw information, and then I kind of format it just the way that I actually want it. But you can see, you know, the main, I mean, you can kind of see what's happening here. I'm going to sum up all the sessions that are on CPU. Okay, I'm going to sum up all the sessions that are on CPU and that are in the middle of a parse. So this is my on CPU in parse count. I'll say sum up all the sessions that are on CPU and in the middle of a hard parse. So these are my on CPU in hard parse. Okay, and then there's the weighting stuff and some categorization and all that. So let's go ahead and actually run this and actually convert the raw numbers into percentages. So here's an example here over the last minute, 362 sessions, 362 samples of active sessions. That's how many, that's our stack of pictures. 97% of those are on CPU, which means way over here, 2.8% were waiting. Okay, so let's get a breakdown related to parsing, related to CPU. Okay, so 97% of the samples actually say on CPU. In addition to that, about 88% of our samples, they actually say parsing. And get this, 63 of those samples, they actually say hard parse as well. I mean, that's one of those insane situations right here. We do have a little bit of waiting. It's not IO, it's waiting on a non-IO wait event. All right, so we'll just run a couple of these. You can see what's going on. Now we're going to run the second part of the script, which is going to give me the actual wait part. And so we can see here's the waiting part. That's related to what we see here. And you'll notice that the top wait event is latch shared pool. That's the main component of this other right here. And you notice when we have latching issues, it's really, or not latching, but when we have shared pool issues, it's really common to have parsing issues because there's a lot of shared pool memory management, and the shared pool latch is used with that. Okay. All right, so, and then we have library cache and this control file parallel, right? That's what that little 11% of the right there. Okay, so this confirms that there is not just a parsing issue, it's a really bad parsing issue, and it's a really bad hard parsing issue. So the question now is, what is the SQL? Let's see. Oh, Babu, hey, I just saw, I don't know how long that's been there. Oh, that's been there for quite a while. Oh, I got to stop this thing. What did I do here? Okay, no, we're good. I'm going to answer your question. I forgot to pause the recording there. So in this analysis, all based on default settings or any other settings need to be put in place. Oh, really good question. All default. There's no underscore parameter changes. There's no ash changes, anything like that. Yeah, really good question. Okay. All right, so let's continue on here. What are we going to do here? We're going to, okay, we're going to be looking for, I think we're going to go for the top SQL ID right here. Okay. Oh yeah. Okay. So this is my like top anything script right here. So what we're going to do, it's just actually, I'm just going to do a list here. Okay. What we're going to do, we're going to do select count star of some columns right here. So we're going to do select count star of the in parse and in hard parse and SQL ID columns. Okay. From $, active session history, all that kind of stuff. Okay. So let's run this. And it's going to get, the plot's going to start to thicken here. Okay, so what we're looking at here, this is the count. So there's, in the last minute, we have one sample of this SQL ID that we caught parsing and also in a hard parse. We also have one sample of a different session, all right? Actually, it could be the same session, but we have another sample of a session running this SQL ID. We caught parsing and then a hard parse. Now, if you think about this, we don't want, as DBAs for parsing performance issues, we do not want a SQL statement to be executed once. We want it to be executed repeatedly, because every time it's executed once, that one execution includes not only a parse, but a hard parse. And we can see that right here. So when you see 1, 1, 1, 1, 1, it's like, wow, we're not rerunning these things. See, what we want is way up here at the top, where we're going to see where this SQL statement is run multiple times. Okay. That's what we're actually looking for, something like that. But we have all these single execution statements that we catch parsing, and most of them we actually catch in a hard parse. All right, so the plot kind of thickens, and we're going to say, okay, okay, realize that there's a lot of parsing overall in this instance. We've confirmed this, and then we're finding all these SQL statements that get executed once, and they're being hard parsed. So what is this? What's the underlying SQL? So let's take a few of these and let's look in $, like what SQL text, and try and figure out what these things are. Okay. So what I'm going to do, I have another toolkit called the OraclePub System Monitor. This is not a rocket science script. It just pulls from what $, SQL text, something like that. But it's kind of a key value thing. So there's the name of the script. Here's the SQL ID. And I'm just going to copy and paste in the SQL ID. It's going to pull out the text. Okay. You guys probably have a script just like this. So there's nothing rocket science here. So I'm just going to copy and paste, and be aware that this script, this SQL like just ran a couple seconds ago, right? And I get no rows back. Like, what's up with that? So I'm going to pick another one. No rows back. I'm going to pick another one. No rows back. So I'm like, I can't get the SQL, but the thing just ran. So if you think about what's happening right here, okay, is that, okay, a SQL is being presented to the foreground process, says, you got to parse this thing and then execute this thing. So it right away figures out, hey, this thing is not in the library cache. I'm going to have to hard parse this. So it does, and then it executes it. And then it never gets executed again. And this is happening so frequently that that cursor gets, like that cursor memory, it gets deallocated and reused right away for another SQL statement, which probably gets executed one time as well. So there's so much like thrashing going on in the shared pool right now, is that we just can't even find the SQL text. So what do? I thought, okay, well, and I actually have done this before. I thought, okay, let's create this like dynamic SQL to very quickly basically create this command right here. And I can just copy and paste and get the SQL right away, right after it's run. So there's my dynamic SQL, right? There's that right there. It's going to create a command which I'm going to run, or it's going to create the SQL I'm going to run. So boom, I got up like real quick, copy that, paste it. Let's see what we get. No rows. Those SQL statements just ran. So this thrashing is like so bad right now. There's no way we can actually get it. So I'm thinking, okay, we got to come up with a different approach. Okay, now it's really common with parsing to have distinct text in a SQL statement, but it's a very similar SQL statement, and their force matching signature is likely to be the same. So how about if I find the force matching signature that has all the parsing related to it? If I can do that, I bet you I can actually get the actual SQL text and figure out like, what's the module, where is this thing, all of that kind of stuff. So what we're going to do, I'm going to try and find the top force matching signature. So see, before I said, give me the top, or just give me the in parse, and in hard parse, give me the SQL ID. Now I want to say, no, forget the SQL ID, because that I can't get the SQL from that. But I want to know what the force matching signature is. And by the way, let me know what the module is, and also the wait event. Okay. And so we're going to find the top. We're going to run the top of this super simple SQL. We're going to execute this. Here we go. Go. Okay. Now, okay, here we go. So the top force matching signature, over the last minute, we got 203 ASH samples right here that are parsing and hard parsing. There's the force matching signature. And we have 54 samples same force matching signature, we caught parsing, but not hard parsing. And then we caught some other ones where we actually weren't hard parsing, and we weren't parsing. We were, I guess, just executing this thing. But you'll notice it's always the same force matching signature. By the way, you'll notice when there is no event here, it's empty. How can we have no event, but it's active? It's because we're on CPU. It's either on CPU or waiting. And so when it's waiting, we actually have a wait event right here. And notice the wait event. They're like share pool latching type, a share pool, library cache type wait events. Okay, now we have the force matching signature. Maybe we can actually get the SQL. Okay. Oh, we know the module. Now this is SQL Plus. That's because I'm putting the load on this. But if this was real life, this module right here would be very useful for you to, in the code, like, where the SQL is. And now, okay, so why is this important? Because you might not, going to the vendor and say, listen, you got to use, cursor sharing equals force. They're like, we can't do that. It's going to blow up the application. I'm like, okay, well, okay, then you need to use bind variables. No, we can't rewrite our entire applications to do that, because you can't afford to pay us the time it's going to take to do this. We got to come up with a better solution. Okay, so how about if I tell you the SQL statement that's causing the parsing issues, and I can tell you where in your application that SQL is. Can you fix that one statement? Okay, we'll try. You see where I'm getting at? This is how we can actually use this. We can tell them the SQL, where it is in their application. Please, if you fix that, that will solve our hard parse or our parsing issue. That's what we're going for here. All right, so super simple SQL right here. Okay, I'm using a define for my my FMS. Okay, I set that to the force matching signature right here. Okay, and so here's the SQL. I'm pulling from $SQL right here. I'm going to show this, the SQL ID, force matching signature, the hash value. So the hash value is a hash of the SQL text. Okay, which is kind of what the SQL ID is too, and that's used to locate the actual SQL text. Like, where in the library cache is this SQL text? Where's the cursor? Your foreground process will hash the SQL text, which will point to where the cursor is if it's already in the library cache. And that's the hash value. The plan hash value, it's a hash of your plan. So Oracle can say, okay, what's the plan? Okay, is that plan already in the library cache, right? Do we already have a record of that? Well, we're going to use the plan hash value to go look and see if it's there. So there's different hash values. I know it can be kind of confusing. Okay, so what this lower SQL text, I wish that wasn't there. I just know a little bit about the application. So this SQL text, like where it's not like $SQL, that's because I don't want to pull back this SQL statement. Okay, whatever. All right. But this is the key where clause, right? Where force matching signature equals my define, my FMS, which is this value right up here. Okay, so let's go ahead and run this. Let's find the force matching, or let's actually look at the SQL text. Okay, there it is. We got 10,000 rows, 10,000 rows, 10,000 unique SQL IDs for the same force matching signature. So look at the SQL statements right here. Are they similar? Yes, they are. Are they distinct textually? Yes, they are. Therefore, they have different SQL IDs. They have different hash values. So every time one of these gets executed, it's not only just a parse, it's a hard parse. They get executed once, gone, memory's deallocated to make room for another one, almost just like it. But you'll notice the plan hash value, it's the same exact plan, but it's textually a different SQL statement. By the way, you see the child number? 0. One parent, one cursor, execute it. That's all we're ever going to do with this thing. All right, so did I say where the module is yet? Oh yeah, SQL Plus. So we know where the module is. That's really easy to figure out. And now we actually know the SQL within the modules. So now we can actually go to the developers. Okay, so there we go. So that's basically the end of the demo right there. So there was our situation. There's the objectives. And at the very end, here's our summary right here. Okay, so what we did, we detected that there was a parsing issue that we cared about, because we profiled, right? We looked at the entire instance. We said, man, there's a lot of parsing. There's a lot of hard parsing. So we can see that there was a lot of samples that were on CPU that were parsing. Something that was really difficult to tell with an AWR report at this level of detail. Okay. Then we found the top parsing SQL IDs, which there was like a gazillion of those. We couldn't get the text. So we said, let's use the force matching signature to figure out the SQL. This part right here, no way we're going to figure that out in an AWR report. Okay. ASH data, we can do that really, really fast. You can see. So it actually, it helped us solve this problem right here. So it's time to talk to the vendor. So they do have solutions. Hey, you know what? If you guys can't fix this and we still have performance, well, then we need faster and more CPUs to deal with all this parsing. Or we're gonna have to reduce our business workload, which we can't do that. That's why we bought your application. Or how about you implement bind variables or bind variables for at least that one SQL statement that we found. And we can tell you where it's at because we know the module. Or maybe you can support cursor sharing equals force. Now, I'm not, by the way, I'm not like a big fan of cursor sharing equals force, but it actually may work well in this situation. So ASH will tell us if we have a parsing issue brewing before it explodes. Now, in the demo I did, it had already exploded. But because we get those counts of a session that is on CPU and parsing or hard parsing, you will start to see that before you start to see any wait events related to parsing. Okay, now, because this, remember, I didn't show you this, but that's just the way it works, right? Like if this is a glass and this is all the CPU power, if we start to use up CPU, right, a certain percentage of that CPU is going to be related to parsing. And ASH can give us information about the percentage of that well before it spills over and we see the wait events. So that's one of the really cool things I like about this, is I can see the problem kind of brewing before it just gets way out of control. Or if I suspect there's parsing, I can actually figure that out. Okay. All right. Oh, by the way, this situation will work even if the Oracle's time model, if the numbers don't add up right, or you're on AIX and you're like, well, what is the second of CPU anyways? What does that even mean in a virtual cloud, environment where resources are being shared? This will work in those situations as well, which is super cool. So there you go. That's how we can detect parsing issues. All right. So if you guys want to actually, look at the recordings, and I guess you have those, but you can actually download this up. I'll put all that online for you. The scratch pad is what I used today. Okay. And if you haven't downloaded or checked that out, you should, because it's really simple. And it's really powerful. If you just use ASH, like by referring to it in the AWR report or even running Oracle's ASH report, it's like you're being ripped off, okay? Because ASH is so much more than what's in those reports. And I hope you can see today that, man, you can do some really amazing things with ASH, okay? If you really want to take your ASH skills to the next level, I've got a full-on class, multi-session homework. We talk about it, we dialogue, all that. Specifically on ASH, okay? And I talk a little bit about some of the other resources on my website, okay? Don't forget about that machine learning class or that e-course. Thank you guys for listening. I know this is kind of at the end of your day, and it's the end of my day too. So thanks for listening. I hope this was useful to you, and it gives you like a new appreciation for ASH and some of the things you can do. And I know there's a ton of stuff that we can do with ASH that we really haven't even begun to do. So maybe that'll be another presentation. But thanks for listening.
Thanks, Greg. Thank you everyone for
welcome.
your participation today, and please do not forget to register for another great session in the conference and to interact with the speakers in their playback session page. Please enjoy the rest of the conference.
All right. Thank you, guys.
Thanks.